Hello everyone, Dr. Vaughn. This is week guidance for week 4, where we're going to talk about analysis of variance. I'm going to give you a few notes just here off of my whiteboard, and then we're going to jump into some of the Excel activities, and we'll go back and forth a little bit between it. First of all, the name, analysis of variance, is named as such because you're actually going to look at the variances, the spread between these groups, as a way of making a conclusion about your hypothesis for group means. So even though you're using variance, we're actually using variance to hypothesize about the group means. Now, you could think about analysis of variance as being an independent samples t-test with more than 2 groups. So you have group A, group B, group C, and maybe more. And you're testing to see whether the population from which A was drawn is the same or is different from the population from which B was drawn, and whether those are the same or are different from the population from which C was drawn. So these are supposed to be the sampling distribution on the population from which A came, the sampling distribution for B, and the sampling distribution for C. And at least in this case, we look at this picture and suspect that they're different, because the distributions are different. And so the mean of the population itself would be these midpoints. And you can see again that the sample that we get from A could be way up here. The sample we get from B could be way down here. So our samples, if they're in this overlap, might not look like they're very different from each other. But along the whole sampling distribution, they actually are different from each other. So the way in which the analysis of variance works is, first, you're going to make your statement of your hypotheses as usual. And unlike the independent samples t-test, we're going to have more than 2 groups. So we say that the mean of group 1 or A, the mean of group B, and the mean of group C are all equal to each other under the null hypothesis. There's no difference between these groups. And then the alternative is that at least one of them is different. They don't all have to be different. B and C could be the same, but A could be different, in order to accept the alternative, which means that we're rejecting the null hypothesis. So this is both a benefit and also a little bit of a challenge, as I'll talk about in just a minute. But I wanted to be very clear about the way in which the null and alternative hypothesis are set up for an ANOVA test. And we're just doing 2 tail tests in this case. It's all going to come out to be 1 tail at the end because we're using an F distribution, just like we did for the testing for the sample variances are the same or not in the last chapter. So what we're going to do on these different distributions is, in essence, look at the how spread out each of the distributions are from each other. Okay, so this is the difference between A and B, this is the difference between B and C, and this is the difference between A and B, just drawn onto the graph in a visual format. So we're going to call this the between variances. And there's 3 of them. There's a variance between A and B, there's a variance between B and C, and so forth. And so we're going to consolidate those between group variances into a single measure, which is the mean squares between. And then we're going to compare that to the variance just within A, and just within B, and just within C, and combine those together to get the within group variances. So we have the between group variances and then the within group variances. And then we're going to take this ratio of the between divided by basically your F observed statistic, your F statistic, is going to be the ratio of this between group variances, which is measured by the mean squares. So we call it MSB, mean squares between, divided by mean squares within. And so it's a ratio of variances, and therefore the name analysis of variance. Now, when you're doing an ANOVA test, there's a couple points that I want to make. And now I'm going to jump in. This is actually the Excel sheet. I thought I had it here somewhere. Okay, here it is. This is the Excel sheet for your Excel activity 1 in 13.1. And what I wanted to point to is this region on the screen, because this is what we call an ANOVA table. All right, this is the result of an ANOVA test, is put out into a table like this, and then the rest of it's like interpreting that result. Now, over here is just kind of, you're getting used to this by now, the result of when you type some formulas in here. We'll go through this stuff in just a minute. But, there's formulas for the sum of squares. And these you either memorize or go look up or write down. And there's formulas for the degrees of freedom, for the treatments, the error, and then the total. The sum of squares, this plus this has to add up to this. So if you have any two of the three of these things, you can figure out the third. Similarly here, the degrees of freedom, the first two total up to be the third one. So if you know any two of these three, you can figure out the rest of them. To get the mean square, you divide the sum of squares by the degrees of freedom. And then to get the F, you divide the mean square of the treatments, that's the between group variance, by the mean square of the error, which is the within group variance. So you to get the F statistic, you divide this cell by this cell, and then you can use the F distribution to translate that into a p-value, which is the probability of getting a result more extreme than what you observed. So at the end, you can just interpret whether you accept or reject the null hypothesis by looking at the p-value and comparing it to your level of significance, which is the alpha value, just like we did on all of our other hypothesis tests. Now, what I wanted to point out, and this is, there's a benefit and then there's also a challenge to doing ANOVA, as opposed to multiple independent samples t-tests. You see, I could have just done an independent samples t-test to detect if there's a difference between A and B. And I could have done another independent samples t-test to see if there's a difference between B and C. And then I could have done a third independent samples t-test to see if there's a difference between A and C. And that would kind of answer the same question. Is there a difference between these group means? Just look at them two at a time. Well, when I only have three groups, that's three different independent samples t-tests, and it grows exponentially. If I had four groups, it's not just four, it's 6 or more. Yeah, I think it's 6. And then it grows. If you have 5 groups, it's even more than that. And 6 groups, it gets really crazy how many independent sample t-tests you'd have to do. So one of the benefits of doing ANOVA is I could test for all three of these at the same time. The bad news is, the trade-off is, if you actually get a low p-value over here, all you know is that there's a difference between two groups, but what you don't know is which two groups. So when you get a positive result, in other words, a reject the null hypothesis, then you have to go on and do something called post hoc analysis. And it's not actually on this particular activity. You'll see it in some of your other work later in the chapter. But this post hoc analysis is the process of saying, okay, I know that there's a difference somewhere, a significant difference somewhere. Now I'm going to go back through and actually figure out where that difference is significant. And there's also another challenge that arrives when you do that post hoc analysis, because your alpha value, which is the probability of making a type 1 error, it would kind of get duplicated. So if I have a 5% chance of making an error, and then I'm going to try that 3 different times, I actually have more than a 5% chance of making that error. So you have to take that probability and divide it by the number of pairs of groups in order, and then look for you have a tighter margin on each pair, because you have multiple attempts to kind of detect that. In other words, multiple attempts to make that error. So if you want to mitigate the overall type 1 error by alpha, you have to divide alpha by the permutations that are possible for the number of pairwise groups. So that's one of the complexities that comes into analyzing your ANOVA result, but it only occurs in the case where you actually detected a significant difference. If this p-value turns out to be larger than alpha, then there isn't any significant difference, and there's no need to actually do a post hoc analysis. All right, so I know that all these terms may not make sense to you right off the bat, but I wanted to give you a general introduction to some of the conceptual idea behind ANOVA, and also the challenges and opportunities of using ANOVA as opposed to maybe some other options. So what I'm going to do for the next couple of minutes, we're probably not going to fill out all of this, is just kind of get you started on this template. This is, again, 13.1 Excel Activity 1. So in here, what I'm using is a count. I have 6 items from method A, 6 items from method B, 6 items from method C. So in this cell, I used a count function, counting how many numbers there are. I could have just typed the number 6, but they want me to use these formulas. And then the formulas will show up over here. And then in the next cell down, so once you get the first one, if you're not familiar with this, you can use the autofill feature. So the autofill feature, you grab the corner and then you can just drag over and it'll copy the formula over. In the next cell, I just did the sum because it wants the sum of all these numbers. And then again, I did the autofill off to the right to get the sum. The next one, they want the mean. So now I'm going to do equals average. And again, click and drag through the cells and close parentheses. Average is 156, and then I'll drag it over. Next, they want the sample variance. Okay, so equals var.s for the sample variance, var.s, and I'll click and drag, and then drag it over. And finally, the sample standard deviation, so equals stdev.s, the sample standard deviation, and click and drag and close parentheses. All right, and then drag it over. I'm not going to really worry about how many decimal places I'm displaying right now. Okay, now I need to go in and figure out the grand mean, the group count, and the observation count. Now, this is where I would suggest that you actually have to look up these formulas for the grand mean, and then you're going to need to look up how you use the grand mean, the group count, and the observation count to compute these sums of squares. And again, you only need the first two because then you can add them to get the third, which is the total. So what I would do is go back and forth again between the video where they'll walk you through exactly what those formulas are, and then type them into your Excel worksheet over here. You could also pop open your textbook. Always a good idea to read the textbook for the grand mean. Basically, what you're doing is you're treating these as if they're all in the same group, and then you're finding the mean of everything all put together. There's also a mean of the means. You have your sample mean, your sample mean, your sample mean. And in the case here where the n's are equal, I have 6, 6, 6. The grand mean is the mean of the sample means. But in general, if the groups are different sizes, that may not be true, because one of those means might have greater weight because it came from a larger number of data values. So just be careful with this formula for the grand mean with what might work in this particular activity versus what might work in some later activities. Okay, so your next thing is to fill these out. There are 3 groups here. I could also just equals count how many groups there are. That didn't seem to work. Okay, maybe I need to do count. Just do it the numbers instead of the titles there. Okay, so there's 3 groups, and then the number of observations. There's 6 observations in each of those 3 groups, and so basically I want this to turn out to be 18. All right, so I think that I'm going to end this video at this point. This is a brief introduction to ANOVA and getting you started anyway. I know that there's still a lot of work to do on this particular activity, but we got about a third, maybe a half of the way through. Some of the more complicated formulas are going to be right in this section in these 2 areas, and then everything else is going to be pretty easy after that. Just divide and the p-value, you got to use that inverse f distribution or the f distribution function in Excel. Look for the f.dist.rt to get that p-value once you have this f observed value. All right, well, please let me know if you have any questions, and I'll try to push out maybe another video. I'm going to see if this saves, and if not, maybe we'll pick up on this one about Monday or Tuesday, and hope you all have a great week. Talk to you later.